Next, we want to look at solving systems of equations by elimination. Now, technically, you can solve any system of equations when you've got two lines, either by substitution or elimination. It's just elimination is a whole lot easier when you can't get a variable by itself neatly. So if you look at this first pair of equations in problem A here, what you'll notice is we have a 6x and a 5y and a negative 6 and a negative 11y. So the problem with this one is if you tried to get any of the x's or any of the y's by themselves, is you'd end up at the very end dividing by something. You'd end up dividing by either like a 6 or a negative 6 or a 5 or a negative 11. Any of these ways we'd end up with really not pretty fractions. That is when you want to avoid substitution and you'd rather use elimination. Now this particular one is already set up for elimination, so let's see how it works. We don't actually need to do anything to actually do elimination. Elimination says that we want two of the variables to eliminate when we add the two equations together. Well, if I add these two equations together, there are two variables that will eliminate right off the bat because we've got a positive 6x and a negative 6x. So when they add, they will cancel out. And then we can just combine the rest of the terms normally. We've got a 5y added to a negative 11y, which will give me negative 6y. Equals, on the other side, let's see what we have. We have a negative 7 and a 1 that we're adding, which will give us a negative 6. Well, then solving it like a normal equation, I divide both sides by 6, and that would get me y equals 1. Again, just like all of my other previous problems, that's only half of my answer. I still need to find my x value that matches up with this y. So how do I find that? I'm going to plug it into one of my two equations. Does it matter which? No, because this is going to be a point where they cross. Both lines will have this equation. They'll both have this point. So pick whichever one's easiest. I'm going to pick the top one because it's got less negatives in it. So we'll use the 6x plus 5y equals negative 7, but you could have easily used the other equation. And I'm going to plug in my y equals 1. So I'm going to plug in for y a 1. So what that will do is that will get me a 6x plus, 5 times 1 is 5 equals my negative 7. Solving it normally, I'll subtract 5 from both sides. And let's see what happens. I will get a 6x equals negative 12. Then I can divide both sides by a 6, and that will get me that x equals negative 2. So putting these two pieces together give me a final answer of the point negative 2, positive 1. That's where my two lines are going to intersect. Let's look at another problem. Let's look at problem B. In problem B, it's not set up for elimination yet, but this is definitely one we would want to do elimination with because all of the x's and all the y's have a number out in front. So getting a variable by itself would be really messy. So we really wouldn't want to do substitution. So the question is, how do I make elimination happen? Well, I need to pick out a variable that I want to eliminate. Let's choose x just for simplicity. So the question is, what number can I turn both x's into? Well, I have a 2x and a 3x. I can turn them both into 6x's. But remember, with elimination, one needs to be a positive and one needs to be a negative so that when I add them, they'll cancel out or eliminate. Well, let's start out with the first equation. To turn that 2 up on top into a 6, I'll multiply the whole thing through by 3. This will become a 6x plus 9y Then don't forget the 3 also has to get multiplied by the 19 on the other side, which will get us a 57. Then my second equation, in order to get a 6x, would have to get multiplied by a 2. But I need the other one to have the reverse sign, so I'm actually going to multiply the whole thing through by a -2. So multiplying by a -2 would get me a -6x, a positive 14y, and a positive 12. Then I'll just add my equations. That's what elimination wants me to do. Now again, remember, we're doing elimination so that they will eliminate, they'll cancel out, and that's what happens with the positive 6x and negative 6x, they'll cancel out. Then we have, let's see, the 9y and the 14y, which will just get added normally to become a 23y, equals, on the other side, what do we have? On the other side of the equation, we have, let's see, a 57 and a 12 that are getting added together, which will be a 69. So continuing to solve this thing normally, we'll divide both sides by a 23. And that will get me that y equals, let's see, 3. Again, we're not done. We still need the x that's going to match up with this to give us our full point. You can choose either equation. I'm just going to choose the one that I think is the easiest, which is the 2x plus 3y equals 19, the original equation. Why? Because I haven't tampered with it, so I know it's probably not going to give me any errors or issues. So I'm going to plug in the 3 wherever there's a y. So plug in my 3 wherever there's a y. That gives me 2x plus 9 equals 19. Now to solve this equation and finish this off, to get the x by itself, we'll subtract 9 from both sides, which will give me 2x equals 10. And then we'll divide both sides by 2, which will get me x equals 5. So my final answer for this problem is that these two lines intersect at the point 5, 3. Because remember, our x, even though we found it second, was 5, and our y was 3. Let's take a look at problem C.